This is pre-calculus, page 17, number 8, and the question says, state the domain of G composite F of X. Remember, when you talk about composition, you state the last one first, so it's G composite F of X. So in the domain, the way we're going to tackle this, and I have my F here, I have my G here, the way that we are going to handle this is that we are going to I guess I can't get rid of that. That's okay. The way that we're going to handle this is that we're going to look at what the composition means. So my G composite F of X equals F of G of X. Okay, which means, let me do this on a new board here. That means that I want to do F of, and then I want to put in what G of X is, and G of X is X plus 3. Okay? And this is the first round of where you have to figure out any domain restrictions. So are there domain restrictions for X plus 3? And in particular, for X plus 3, the answer is no. There are no domain restrictions. The domain of G of X equals X plus 3 is all real numbers. So I don't have to worry about that in this one, but in others you may have to worry about that, and if you do, you need to write it down. Okay? So now let's go on to calculate this, and the easiest way to do it, actually, let me get rid of that and have some room first, because let me write down what F of X was. F of X was 1 over X minus 2 all squared minus. And so then F of X plus 3, the way you do this, the way to not mess this up, is you go into the F of X function, you go into what it equals, you put parentheses around just the X, and you replace those parentheses with these ones. In fact, let me do these parentheses in a different color. I'll do them in blue so you can really see. So these parentheses get replaced by those parentheses. Okay? And it looks like this. So parentheses, that is those parentheses right there, and then the blue parentheses, and I'll put in X plus 3 minus 2, close parentheses, those parentheses, and then squared. So there's what my new one looks like, and I'm going to need that, so let me start that on a new board. So F of X plus 3 equals 1 over X plus 3 minus 2 all squared, like that. And then I want to simplify this as much as I can. I don't really need the inner parentheses, and I can put together 3 minus 2, so it can look like this. x plus 3 minus 2, and then I can focus on this. Oh, and that's all squared. So it's 1 over x plus, and then 3 minus 2 is 1. So it's x plus 1 all squared. And then, let me do some side work here. X plus 1 all squared. That means x plus 1 times x plus 1 again. And this is then this distributed to these two things, so it's x times that x plus 1 times that x plus 1, and I can distribute those, so x times x is x squared, plus 1 times x is x, plus 1 times x is x, plus 1 times 1 is 1, so I get x squared plus, and then x plus x is 2x plus 1. So I can write this, I can write it without the parentheses now, x squared plus 2x plus 1. Now I have, but you know what? That actually wasn't a good idea for this problem, and I'll explain why. Okay? So normally this would be like sort of the finished version of the problem. However, we are concerned with the domain, and the domain means finding restrictions, and in the restriction area, that is in what we're talking about, where this cannot be real, where you can't generate real answers, what we're talking about in a fraction is where the denominator equals 0, and the denominator can't equal 0. So this domain is actually, the fact that we want the domain means we should leave it like that. So let me go to one more new board, and so now I've got the composition, okay? G composite f of x equals 1 over x plus 1 all squared, and I'm going to write it that way because for the domain, what I'm going to do is I'm going to say, okay, that bottom thing cannot equal 0, okay? That bottom thing cannot equal 0. That denominator cannot equal 0. And I am going to solve this and figure out what x then cannot equal. Now, it's probably pretty obvious and elementary, but I'm going to go through exactly how you do it. You'd square root on one side and plus or minus square root on the other side, and then the square root would cancel the square, leaving you with x plus 1 cannot equal, and then plus or minus the square root of 0. Square root of 0 is 0, and the positive 0 and negative 0 are the same. And then I subtract 1 on each side and get that x cannot equal negative 1. It's actually that x cannot equal negative 1 twice. I can show you this in another way. Instead of writing x plus 1 squared, I could write what the multiplication actually means, which is x plus 1 times x plus 1. And then you use zero product property to say either that first thing cannot equal 0, cannot, or that second thing cannot equal 0, and then you solve them both. So x cannot equal negative 1 there, or x cannot equal -1 there. So it's actually x cannot equal -1 twice, but it's a semantic thing at this point because we're just trying to describe the domain, and it doesn't matter how many times x cannot equal -1 in the domain. All we care about is that the domain is that x cannot equal -1. So there we have that. Thank you.